All right. So, we're going to in section 7.7, continuing with chapter 7. We are going to look at those mole factors and how to do mass calculation using moles and mole factors in reactions. All right. All right. So here you have acetylene undergoing an oxidation or a combustion with oxygen. All right. And that is then used for welding of metals that flame, oxyacetylene flame. So the mass of acetylene that is used to weld that specific mass of metal can then be calculated using all these mole relationships. So here, this is called a stoichiometry, where you're converting grams of reactant to grams of product. All right. And so you're taking your grams of reactant, say A, you're using the molar mass divided by the molar mass, then you get moles of the reactant A. And then you use the balanced reaction between A and B, use the mole factors to convert it into moles of B. Once you have the moles of B, you multiply by the molar mass to get the grams of B. So here you have nitrogen and hydrogen forming ammonia. All right, so 1 mole of nitrogen, 3 moles of hydrogen, 2 moles of ammonia. So you started out with 32 grams of nitrogen. So how much grams of ammonia can you get? All right, so take the 32 grams of nitrogen, divide it by the molar mass of nitrogen, which is around 28 grams. Right, so 32 divided by 28, you get the moles of nitrogen. Then convert the moles of nitrogen to moles of ammonia by the mole relationship between nitrogen and ammonia. So you know that 1 mole of nitrogen is can be converted to 2 moles of ammonia, because that's the relationship. All right, so whatever moles of nitrogen, you multiply it by 2, that gives you the moles of ammonia. Once you have the moles of ammonia, then you take the molar mass of ammonia and multiply it. All right, so the molar mass of ammonia is about 17, and so you'll finally get the grams of ammonia. So it'll look like this. All right, so grams of nitrogen, divide by the molar mass, you get moles of nitrogen. Moles of nitrogen, you multiply that by 2 and you get moles of ammonia. Moles of ammonia, multiply by the molar mass of ammonia and you get the grams of ammonia. Okay, so mole of nitrogen, approximately 28 grams. Mole of ammonia, around 17.04 grams. All right, the relationship between nitrogen and ammonia, 1 mole of nitrogen to 2 moles of ammonia. So 32 grams of nitrogen divide by the 28 grams of nitrogen. All right, so you get your moles of nitrogen multiplied by the 2 moles of ammonia, and now in moles of ammonia, and then you multiply that by the 17.04 grams of ammonia, the molar mass, and you get the grams of ammonia. Okay, sig fix, 2 sig fix. For here, this anything that is 1 is exact. These are exact when you have single digit numbers like this, whole numbers, and then you have 4 sig figs here, so the least sig figs is 2, so your final answer is 2 sig figs. All right, how many grams of oxygen are needed to produce 45.8 grams of iron 3 oxide in the following reaction? All right, so you have 45.8 grams of iron 3 oxide. Okay, take the grams of iron 3 oxide, convert it into moles of iron 3 oxide by dividing grams by molar mass. Okay, Once you are in moles of iron 3 oxide, you know that for 2 moles of iron 3 oxide, you get 3 moles of oxygen. So convert that into moles of oxygen. Once you have the moles of oxygen multiplied by the molar mass of oxygen, around 32 grams, to get the grams of oxygen. Okay. So the answer is B, and this is how you get it. You take the grams of iron 3 oxide divided by the molar mass, and then the mole ratio is 3 moles of oxygen to 2 moles of iron 3 oxide. Okay, and then you finally multiply it by the grams of oxygen and 3 sig figs, so 13.8 grams of oxygen. So the reaction between hydrogen and oxygen produces 13.1 grams of water. How many grams of oxygen reacted? So again, take the 13.1 grams of water, divide it by 18 to convert it into moles of water. Once you have the moles of water, you know that 2 moles of water, to make that you need 1 mole of oxygen. All right, so your moles of water divided by 2 and you get the moles of oxygen, and you multiply it by the molar mass, which is 32. There's 2 oxygen, so multiply that by 32 to get the grams of oxygen. Okay, so 13.1 you divide it by the 18, get moles of water, divide by 2, you get moles of oxygen, and then you multiply by 32 and you get 11.6 grams of oxygen, 3 sig figs. We'll stop here.